Hello once again. It's me again, Al, and moving on to 89. Now I want to show you something, but hang on, I'm going to do something first. Hello again. What I've just done here is restored from an old backup. One of those old versions of that horrible project that I keep calling horrible. And I wanted to show you the one particular function control. Okay. As I was starting to clean this thing up, one of the first functions I wanted to get rid of, well, not necessarily get rid of, it was like the main parsing function. But what I wanted to do was just break it up because it was so long. If I can find it. I have a thing, I've changed a setting on here and it's really bothering me. Something parse something parse. Oops. I'll know it immediately when I see it. It's like parse. It's a weird. Oh, is this it? Parse reader. I think that's it. Okay. Line 220. So that's 200 lines. So here's a 200 line function. Okay. Now at the beginning, 3 variables are set: beg, cur, and end. Okay. You can imagine what those have to do with. Something to do with where we started, something to do with where we are, and something to do with the end. And then there's last, which is current sent initially equal to cur. Okay. Now we're dealing with a windowed reader of a reader. Okay, well, forgetting all that. Now they're all into these do while loops, okay? And what they tend to do is they tend to set this last equals cur, and they go through doing something, and then they get cur from the window reader and set the beginning back to cur, and so there's keeping track of this cur, right? Current position, I suppose. Now, sometimes there's peaking going on, and then sometimes there's going. Sometimes it's going into a seek for some condition, and it tries to restore where it was. Here's one where he reads 3 characters, okay, extra characters, and then goes through one of these seeking things. And then now at this point I have no idea what cur and beg mean anymore. Right, but he's seeking through the file and he's trying to make sense of the data part of it is to try to find where the audio information is, and part of it is trying to find where these headers and trailers and other things are. And that's happening here. Music match, lyrics, version 2 tags, version 1 tags, and then end and cur, changing, etc., etc. Now here's another thing. You can see why I wanted to try and split this up. For one thing, it didn't even work. It's full of bugs. One of them, for instance, was this assumption that a sync byte was only a single byte. In fact, for these audio files, what they call a sync sequence is 11 bits worth of ones. So that's only 8. And so that turned out to be a mistake in some files. But the thing is, though, if I bytes till sync, it goes ahead and it goes all the way to the end of the file, and then it comes back again. So it's going backwards and forwards and trying to keep track of where it is and what's going on. So I realized, I said to myself, I don't have a current one, I can open it. This My Projects thing is great. So remember that was called Parse Reader or something, right? Now what I realized was that if it did like just a quick pass through the file first and get a general layout, then you could simplify that function tremendously and not have to go backwards and forwards. You would know where everything was, even if it hadn't been parsed yet, right? And then do everything in order. So now that parse reader has been reduced, if I can find it again. Main files. In this particular one, I have a function with an aim, something like, get a general idea of something. File. Hang on, I'll pause this. Okay. Yeah, see? I found it again. Here's that function. Remember the 200-line function? So I invented this function called parse overall structure. So that means it just sort of goes through and checks to see what subsections are there, right? And then I can ask, should we do this? Should we do that? And it already knows where to go. So the whole function has become this. That's like 30-something, 40 lines or something, not even 40. 16, about 30 lines. And there's hardly any code, right? It has audio, is the only real something happens. Now, so for instance, I'll show you ID3FO is just this one of these demos, and so here when I do the parse, because I have that function, I can print out at the beginning, the layout of the file, see? It has a v2 header, it has this much padding, blah blah blah, the audio data, see this? There's a lyrics, version 3.2, 1000 bytes, there's a footer, there's a v1 tag at the end, name of the file, and then there's the frame, okay, and then each frame has fields, and so on and so forth. All the stuff the thing could never do. And now it has something called lyrics that I've had to add this in by hand. I haven't found an example anywhere online or downloaded thousands, millions of MP3 files, and I can't find anything that uses the lyrics feature. But in ID3 testing or test, you can see, yeah, see, like I've added pictures. I think this one has a picture. Image, there's an album cover. Oh no, see now this is part of that lyrics stuff. That's lyrics 3. Observe. This one doesn't have any picture in it. V1, V2 with image. Let's see. But again, V2 header. See, this is 19 kilobytes header, and the reason for that size is there's this great big picture here, 18 kilobytes worth of picture. What else is in here? The problem with this, my problem with this project, the reason that I'm not able to finish it is I can't find examples. Saying searches, whatever that is. I can't find examples of the cases that I need to test. Well, like the insertion could have been to do with the therapy. That's why it's running slow too. It's debug version. Here's one that's using the format of data called unsynced. Here I put another picture here, mutable. I don't know what mutable meant. And so like for some of these things, when you open them with Winamp, you get extra information and so on. And I have different categories and things I was testing. But I can't test anymore because I don't have enough data. Anyway, as for going back to the animated GIF, you can see the time, not too bad. So I figured in this case I have a similar situation. What I want to do, now you see his thing does the old version This is false, by the way. It is free now. 87A, okay, with some problems. But right now, I'm not even going to worry about that. All I want to do is parse this particular format correctly. right? Even if I don't decode the image, and get a general layout of the file. Okay, now doesn't matter if I can do interlaced or not. The parser will tell me. And then I want to move on to this. So I will start this parsing project. Pre-parse. Now, I hope it still works with his version. What was it? W logos 3. If I run this, okay, it's working. Okay, now this is the old version. I dump out the GIF header. It's 320 by 200, has a global color table, and this is the color table. I printed out just for fun. Binary. Then the local image descriptor. This packed thing is a packed field of flags. That could be 0 in this case. Now I go to reading the data block. And it took me a while to figure out why that wasn't working. And because I was reading this documentation here, right? I don't know where it says it, but as far as reading the data, I mean the actual picture data, you know, eventually you want to actually display a picture. Here, each data subblock begins with a count byte. The value of the count, blah blah blah. The data immediately follows the count byte, and the contiguous group of data blocks is terminated with a 0. So you got all these data things of a given length, right? Length from 1 to 255 until you find a length value of 0, and then you're done. And typically the blocks will be 255 bytes, as they are here. There's 1 byte worth of count, right? And the count is 254, and that's 255 bytes. Now I have a thing that if I press a key, it's going to show me the image data. I'll let that disappear on us. So all this is the data. You know, I could turn that into a picture if I had the decompression algorithm. But now, up in here, I started with this GIF header. Directly take it from that web page, and that web page has a mistake, which got me going for a while. And the mistake is to do with these local image descriptors. This comment is no longer true. He had these bits reversed, and he has them reversed in his documentation. If you look at the color table for version A, for the earlier version, one of either one, there's a global color table and a local color table, right? Not color table, sorry. Image descriptor, or whatever it's called, the packed thing, okay? Bit 0, least significant, okay? The last 3 bits is the size of the color table, and the most significant bit tells you whether or not it exists, okay? That's the logical screen descriptor. Now, local image descriptor that also has a path 0 least significant bit. 0 table exists, so that means it's backwards. And 5 to 7 size of color table. You see? It's reversed. But in fact it's not reversed. I thought maybe it was reversed on purpose so that you could tell, maybe tell one from the other. But it's not. They're in the same order. And once I fixed that and got rid of all the assertions and stuff, and there's the name of that file. I wish I could copy that. Copy the text. Okay. Thank you. Now I put that GIF in, which is our animated GIF, not one picture, different version. See, now I added another subset that has all these control extensions, which I have to parse. And my pre-parse loop looks like this. Here that's the switches. First parse the main header, okay? And then while the bytes read is less than the size of the phone minus 1. I wonder why. Oh yeah, okay. Okay, so it works out to the byte. This winds up at a point where there's exactly 1 byte left, and you read it, and these two end up being equal, and that last byte is the 3B trailer that always follows at the end. If I run this, I now have an outline, which I can do. So this is image 0. Okay, host in motion. If it's this version, that's the size. It has a color table, global color table. That's the color table. Okay. It has a control extension, a comment. No, a graphic control extension and a comment extension. I should have put an S here or something. There's a comment extension, that's a different kind of thing. Now, the local image descriptor, okay, is all zeros for pack. And I'm here, ready to view the image data. Image data for picture 0. Now, that came out, printed out, great big long thing. These pictures are slightly bigger, I guess. And now it's reading the next one. Okay, I've gone to image 2. And you didn't notice this happen, but after that printed out, we went and found another graphic control extension. And this one has a transparent color index, the other one didn't. This is the same comment. And this is where I got messed up. It has a local color table. So here's its local color table for the second image. And here's the data for the image. And I can view that image. Okay. So basically now I'm extracting the images, I'm getting their color tables, and I've successfully parsed the data. All I gotta do is figure out how to convert those bytes. How to do the LZW decompression. Image 9. This is the last image. 10. Okay. These bytes have to be decompressed, and that if I can figure out how to isolate decompression algorithm from our PICVIEW buddy, then I should be able to run and animate this GIF. I know the time. Now there are some flags I don't know how to deal with, like, well, I know how to deal with transparency. Look at transparent color index. So if I see a 181, basically I don't draw that. I think this got in probably by accident. But I can just draw them one and then the next. I know that's going to look fine. And I bet these local color tables are identical. Look at all the zeros at the bottom. That could be a mistake in my printout. Not in the file. The file is parsing correct. And so that essentially that problem is solved. Now I can parse all GIFs, right? All I gotta do. Oh, I was trying to say something and I must have forgot what I got sidetracked about the blocks of the blocks of data, compressed data. The documentation certainly says that each subblock begins with a count, right? And typically the count is 255. But I wasn't getting that. I was getting like 8 first, and then weird numbers, little numbers. But then I noticed that the next byte after the 8 was a 254, right? And then if I read in 254, I'd get another 254. And it's true that there's an extra byte that's not, well, yeah, see, now each data subblock begins with a count. But it doesn't mention anywhere here that before the data blocks, there's another number whose meaning I have no idea what it is that I have to read in first in order for it to start reading the block. So that's why I've got this funnily named number. At first I thought it only occurred on the first image, but then afterwards I found out it's the same for all of them. There's some special count, something or other, that always has the value 8 that comes before all those data bytes. And part of the way I found that out was by looking in here, and I saw that he reads an extra byte in before he starts his decoding. Here, this code size, whatever that means, and then he takes 2 to the code size, and then he's adding to that clear code some numbers, and then he's incrementing it, but he hasn't done any reading yet. And now he starts to do the bit reading. So whatever this means, I don't know what it means, I gotta skip past that, and then this loop will proceed, and then it's fine. I'll insert this in here somewhere. Let's take this code, this decoder, and find a way to dump bytes into it and a color table and have it give me back the indices and at each XY. And that shouldn't be hard. So I should be able to do the animated GIF for any type of GIF without having to fake it, without having to use funny palettes, and without having to run that god-awful PaintShop Pro program. And all the information's in the parse, okay, even though I don't know how to deal with all of it, it's all there. That part's solved now. There are other things like, there's a flag that says that the user has to click to go to the next image and so on. You know, I could use that flag or whatever. But the point is, the problem is essentially solved. So that's my update, and I guess the lesson to learn here is that in order to make progress with something like this, right? You don't have to solve everything at once. You know, just see if you can get the layout of the data first, right? And then take it one thing at a time. Now this is all again using globals, right? They're not listed here, but you can think of this whole project, pre-parse, as a class. So everything you see here listed as global, these are members of a class, right? And these are going to be some of the member functions, right? What gets passed into main is maybe the exposed functions or whatever, right? This loop here extracts picture data, right? When the data is extracted, I guess one would save it off into buffers after decoding them, and or you could create, you know, in this case, 11 memory DCs, right? And in order to do the animation, you just blit one or the other of one of those device contexts to the window. Okay, well, that's an update. It's not much to look at, but I'm pretty sure I'll have something soon, within the next day anyway. See ya.